Okay, remember the Magnavox VCR? It's a ZV427MG9 I repaired. Actually, in real time, it's been a couple of weeks ago, but you guys may have only seen it a few days ago. I'm going to end up delivering this unit back to my customer who lives down in the Bay Area, Burlingame area, I do believe. And so these are the old parts. You can see the main filter cap and some DVD caps. I did remove the auto head cleaner. It did not pass my test. And this is the one that had the noisy fan you can see there. So I donated a used fan out of a fairly new unit. I believe it was a new old stock unit. It only had a few hours on it by the looks of things. Here is the front of this unit. I believe I did clean it up a little bit. It was a little bit dirty, but it looks much better. And new fan installed. Cords all taped up, ready to get back to my customer with his original remote right there. And so when this failed, I went ahead and ordered a couple of brand new replacement fans. And I don't know if this will cooperate without a knife. Maybe, maybe not. Maybe some scissors would be a good solution as long as I don't cut any of the wires. So these are a couple of NMB mat fans. And look at that, they're in their own little shrunken, they're not vacuum packed, but I'm not seeing an opening. Oh, yeah, there it is. Just got to pull a little bit harder. And so these are 3-wired fans, but these are dual ball bearing. They're not sleeve bearing motors, so they should last a lot longer. And I did order these specifically because they're exact same current consumption, 0.1 amps. Hopefully we're not on manual focus there. There you can see it, 0.1 amp. Now, these fans do have a tack lead coming out of them that I'm not going to use. So I'm just going to go ahead and cut that off. And then we'll have to rewire this connector to fit the customer's existing connector on this fan. So I think what I'm going to do is let's move a couple of things aside here. And I'm going to go ahead and just pull this fan out, cut the leads off of this fan in the bag, and then I will rewire the leads onto this new fan. We could also do a comparison, new fan to old fan. And I'm just going to go and throw this in here because I'm actually going to be delivering this unit back to the customer in the Bay Area in just a very few days. Actually, by the time this posts, it may have already happened. But let's go ahead and do that. I always fold the tape over when I use something that you really can't get access to easily, just so the customer can get it open or get it off. So if you use packing tape, always fold one end over if you can. And so this is the customer's old fan. And I do believe that we can get zoomed in a little bit closer. Will it focus? It seems to. I believe this thing had a little bit of run out. I think it's probably sleeve bearings in this unit. And I don't know if you can see the movement. It's got a little bit of play to it. But I chose this other fan because it basically has the same specs, 12 volts at 0.1 amps. I want it to be quiet. I could get a much higher current fan, which moves a lot more air, but it's going to make a lot more noise. And that's one of the concerns this customer had, is that the fan was noisy, as you heard. And of course I blew it out and everything got quiet, but I still want to go ahead and replace it. Let's go ahead and hook these up to 12 volts and listen to each one individually. So yeah, one moment. Okay, so I've got my Fluke 87 out here in the milliamp mode, and then I'll bring in this other meter and we'll put it up here. Now I do have a capacitor installed in here. It's not really for noise or anything. It's just because I can attach the leads easily to it. And as you can see, I bent the positive lead because it is longer on these capacitors. It is a 100 microfarad 25 volt capacitor. So I've got my meter right here, and we'll put it in the 60 volt range. And so here is the negative lead, and then this will be the positive lead. And I'm at 12.03 volts. So we can get rid of that meter. And like I said, the 87 over here is measuring milliamps. So when I connect the negative to the negative, we should get milliamp reading. And there it is. Let's move the microphone. Hopefully you can still hear me as I dangle this over here. So I've got the microphone on the back side of the motor, which is the entrance side, so it shouldn't be getting wind buffeting or wind noise. And it does make a little noise when it's on the bench, so I'll lift it up. I'm about a ½ inch away from the rotor right now, so that is the ambient noise of that fan. And it is drawing, 79 milliamps or 0.079 amps. So a little under what it's rated at. Okay, next let's go ahead and get the brand new fan set up here. One moment. Okay, here's the new fan. Everything is exactly the same. I do have the wires into the connector right there. Let's apply power to it and see what the meter has to say. Somebody lied to me. That's not right. That's not what I was expecting. I'm not going to be able to use this fan unless I put a resistor in series with it. I don't know if you can hear it or not, but that thing is moving some air. That's not what I ordered. Well, I think it's going to have to go back with the used fan but that's definitely louder than the original fan was by a long shot. I can see on the VU meter on the screen on my TV. This thing is loud. And yeah, let's get the microphone back up on my shirt. There we go. So yeah, that's not what I signed up for. I mean, this thing is moving. I mean, really? 12 volt DC, 0.1 amps. And as you can see right here, we're drawing 0.16 amps. And this thing is booking. There's no way the customer is going to be happy with this. Although it's going to keep the thing a lot cooler for a lot longer, but no, not happy. Well, they'll go back in the box of fans I have in the garage. And yeah, well, let's try the other one just to be safe, just in case it is a fluke, as the lockpicking lawyer says. Don't eat the wires, don't eat the wires. Well, there's the second one. Let's get the mic disconnected there. And it's virtually identical, even more current, 178 milliamps. I mean, it's not vibrating, even when it's on the desk. It's still fairly quiet, other than it's moving a crap ton of air. So yeah, not going to work out. Okay, well, I thought this was going to be a let's go ahead and just give the customer a courtesy of installing a new fan. So yeah, I'm sure you can hear that whining. It's just, wow, really? So I'll do this in real time. So here's the other fan. Can't see, there it is. 160 milliamps on that one. And then here's the original fan. If I can get it. $78 milliamps. So yeah. That's not going to work out. Not going to work out. Okay, well, I thought this was going to be, like I said, a let's go ahead and install a fan as a courtesy to the customer, brand new one, since I don't have to deliver it yet, but that's not going to happen. I don't think the customer would be very satisfied with the amount of noise this fan produces. All right, well, there you go. Failure. My part? I don't think so, based on what I was ordering. So, yeah, definitely mislabeled, or I don't know. Maybe this is just a crappy sticker over. Did somebody maybe print that out and put it over some other fan? I don't know. I'll keep looking. All right, everyone, thank you for watching. I really do appreciate it. Have a great day. Bye-bye. Not so fast. So I'm just going to reduce the voltage to this fan. Until we get it up to about the same audio level. So there's 100 milliamps right there at 7.4 volts. And let's get the microphone off my shirt. That doesn't sound too bad. It's a lot quieter than the original at the same milliamps. So, like I said, we're at 100 milliamps right there. We're about the same distance. It's definitely quieter than the original one was. Now, will it reliably start at 7 volts? That is the question. Get my microphone connected back up there. So I'm going to kill power to it. Reapply power at 7 volts. It seems to start no problem. I wonder how low it will actually start. All right, so I'm going to stop it right there. And I'm bringing up the voltage very slowly. And so it needs to have about 5 volts to start. So right there, we're at 7.4 volts. Let's verify it with the other meter. And leads are going to be backwards, but oh well. 7.2, actually, according to the meter, the power supply is not quite perfect. It says 7.4, so. And it is definitely quieter, so can I get away with just putting a resistor in series? Or is that going to affect whether it can start or not? It may not have enough to overcome the basic inrush of the stalled fan with the DC motor starter. Well, let me try to figure something out. I'll be right back. One moment. Okay, so looking at the Ohm's Law calculator right here, I need to drop 4.8 volts at 100 milliamps. And so the resistance is going to be 48 ohms because I'm on resistance right here, 48 ohms. So I need to determine what the power is going to be on that resistor. So common value is going to be 47 ohms. So I know the voltage is going to be 4.8 volts. And the resistance is 47 ohms. And so we're going to dissipate about half a watt, 0.49 watts. All right, let me see what I can find. One moment. Well, I do have some 47 ohm 1 watt resistors right here. And so I think I'm going to go ahead and add one of these in series. We'll put the power supply back up to 12 volts. And we'll see what it wants to do. So let me grab a couple of test leads here. I don't think color matters at this point. So we'll disconnect that. Connect one side of the test lead. I'm sorry, that was out of view. And then grab another test lead. Connect it to the other side of the resistor. And, okay, it's actually running. So I'm going to say that's going to be a win. Let me get the power supply back up to 12 volts here. We'll plug it back in. And we're at about 102 milliamps. Let's actually measure the voltage out of the power supply. So there is the positive and there is the negative. And we're at 12.3, a little bit high. I'll turn it down just a hair. Maybe a hair and a half. All right, there's 11.7 volts. And we're at 97 milliamps. I'm pretty happy with that. So I know that this thing will start. So I'll stop it right there. And next I'm going to try to stall it a couple times. and I stalled it too many times and it went into like the limp mode. There, it's in limp mode right there. And it came out of it. I don't know if you saw that or not. So I'm deliberately stalling it. Barely moving. There it goes. Try it one more time. 160 milliamps. There, it's going into limp mode, 43 milliamps. There it came out of it. I should put this on manual so you guys can actually see the peaks. I'll put it on min-max. And waiting for it to try to stall, which it's not doing. There it goes. Okay. I'm pretty happy with that. Minimum 26 milliamps, maximum 161. That's perfectly fine with me. And it's nice and quiet like the original one was. So I'm going to add this 47 ohm resistor in series with one of the leads. And we'll tear this thing apart. I'll donate this fan to the customer at no charge, just to make the customer happy and many, many more years of life out of this unit. One moment. Okay, so the fan is reassembled. I did go ahead and heat shrink the resistor in there. Yeah, it's going to add a little bit of thermal insulation, but I doubled the rating of the resistor basically, so it's a 1 watt when it needed a half watt. So I think it's going to be fine. We'll focus up on the fan here, and we'll apply 12 volts to it right there. And it starts up and it runs. And what about stalling? I just need to make sure it's going to be able to restart. And I think the answer is no without the capacitor. If I just give it some help, it'll be okay. Although, you know what? I don't think it's going to stall. Stop, start. As long as it doesn't go into that limp mode right there. And all it takes is just the slightest little bit to get it moving, it looks like. Then it takes off just fine. It does seem to start. No problem. Let's let it spin down. I'll turn the power supply down and I'll bring it up slowly. And it starts at 8 volts. So there's 12 volts. And I think we're going to be okay. But we'll give it a try. Let's put this thing in. Okay, the customer's VCR is back up on the bench. Let's go ahead and apply AC power. Let it boot up for a second. We'll hit the power button. And then I'll put the microphone down here. Okay, so that's what it sounds like at about a ½ inch away. Let's go ahead and install the replacement fan and see if it's about the same noise level. Oh, and inquiring minds want to know, what is the actual voltage level that it feeds this fan? So power on, and try to get a couple probes down in here. Oh, we're only feeding it 7.8 volts. Interesting. Well, I hope it's going to start at 7.8. I guess we'll find out very shortly. Okay, new fan is installed. Well, plugged in at least. And just sitting here. And it does start. So I'll hit the power button. What about stalling? Okay, I'm pretty happy with that. It is running. So I'm wondering, let's move this, well, kind of over here without it grinding something up. What's the voltage now? Because we have a resistor in series with the fan. Hopefully you can see that there. No, okay, better. Oh, 7.7, same voltage. Well, I'm going to ship it. Okay. Everything looks about the same. We don't care about the yellow wire. It's just going to kind of live there for now. And we do have to get the red tucked in there to be safe. Actually, we can probably take the yellow wire, just bend it around like that. And let's see, that goes down, that goes that way. And then it just kind of lives right there, just like that. Now, is that blowing the right way? Yes, it is. That is out. Okay. Always questioning life's choices. All right, we're centered up. Get these guys started by hand. Hopefully it's still in view. I should have plugged it in first. Yeah, that would have been a good idea. Now let's see if I can. It's hard to see. Gotta get the angles just right. Hopefully my head is not too much in the way. Got it started. Bending the leads over so they don't interfere with anything. Okay, I'm happy with that. Power on. And we'll hit the power button. If anything, I think it's a bit quieter than the original one was. So there you'll probably hear some wind noise. But I am perfectly happy with this. Perfectly happy, and I believe the customer is going to be happy as well. Well, that certainly ended up being a longer video than I had budgeted for, but got to take care of the customer. Everyone have a great day. Thank you so much for watching. Happy New Year. Bye-bye.